Hi everyone, we are Team 10 called KungFu Data. This is a presentation for our project where we implemented, evaluated, and operated a movie recommendation system with 1 million users and 27,000 movies. Our goal was to build a productionized system where we address real world challenges like data drift, feedback loops, and scalability. In our system design approach, we had a Kafka stream where we Dockerized it to listen to logs, clean them, and store them in MongoDB. We also created an inference service in Python using Flask framework and track the metrics using Prometheus and Grafana. Next, Arihant will talk about uh, technical challenges.
So the project was highly open-ended, which required us to make technology decisions for each milestone. Along the way, we faced a few challenges that we would love to discuss. First, in the streaming tier, containerizing Kafka presented significant challenges as we navigated network interfaces between a Dockerized service and the Mongo database, which was outside of the Docker container. For the web tier, implementing an effective load balancer was our primary obstacle. We needed to ensure seamless distribution of recommendation requests without compromising response time. While we successfully containerized the Flask-based API, our attempts to deploy the entire system using Kubernetes ultimately failed due to configuration complexities and time constraints. The storage tier presented unique challenges as well, particularly in data querying. MongoDB's document structure initially complicated our ability to efficiently extract the data needed for model training. Despite these challenges, our project meetings at the beginning of each milestone allowed us to adapt our approach and select technologies that could be integrated with our existing components. Looking back at the project, a few key improvements could have significantly enhanced our system's reliability and maintainability. In the web tier, we learned that establishing Kubernetes early in development would have been invaluable. By implementing container orchestration from the start, we could have achieved seamless replication and zero downtime updates. More critically, our service crashed after milestone 3 due to the virtual machine issues, which went unnoticed because our Grafana alerts weren't properly configured. Setting up robust alerting from day one would have prevented this extended downtime and preserved the recommendation service availability. For the storage tier, our main takeaway was the importance of thoughtful schema design. While our iterative approach allowed us to build a functional system, integrating these improvements from the beginning would have resulted in a more robust and maintainable recommendation service. Now, Abhijay and Anning will explain the model design and challenges faced on the ML side of the project.
Yep. So moving on to the model design, we mainly had three different model architectures. So initially we had just the base model where we compared three different methodologies. One was user-user similarity, one was item-item similarity, and SVD. And going to execution time, SVD performed the best, and other metrics as well, SVD performed better than the rest. So we decided to stick to standard SVD. But the drawback with this was we trained it only on the initial data set and it just served as a benchmark and there was no adaptation to new data and it was a static model. So moving on to our next iteration of the same model, we retrained it on old and new data and this was done periodically every 12 hours. This was a live deployment and it was dynamic, but it still did not do user-specific recommendations, as in there was no specific model for different types of users. So moving to our milestone 3 and our final model architecture, we had two separate SVD models, a primary model and a secondary model, where we segmented users based on the performance thresholds on the primary model. And the users for which the model did not do well were split into a separate database and another SVD model was trained for them. This improved personalization and doing better for users on the primary and secondary models. Here is a model architecture which summarizes this whole process. Moving on, Anning will go through the technical difficulties we faced and other improvements we did.
Now I'm going to talk about technical challenges. We have three, and the first one is data sparsity and SVD stability. Because SVD was sensitive to sparsity in the user item interaction metrics, and we had to carefully choose a number of latent factors to avoid overfitting and manually inspect the smallest singular value to prevent collapse during training. And the second one is versioning and model lifecycle management, because integrating model versioning through weights and biases introduce both engineering and modeling overhead. And the third one is balancing model generalization and personalization. As mentioned in milestone 4, the primary model, which is trained with fewer latent factors, worked well for general cases, but struggle with co-star for niche users. And designing a routing logic that effectively identified these users and dynamically switched to a specialized model require iterative tuning and performance validation. And now for reflection and improvements. The first one is model version control. Initially, we attempted to store everything in the model artifact, including large intermediate variables, and that caused our first save model to reach around 17 gigabytes. And then we later refined our saving logic to include only essential components, like we mentioned here, SVD metrics, movie factors, user IDs, and movie IDs, and that's all. And this made it feasible to track versions effectively and integrate artifact logging with weights and biases. And in the future, we plan to automate cleanup and temporary artifacts and implement checksum-based duplication to avoid logging redundant models to weights and biases. And then the second one is addressing the co-star problem. Since our model rely on SVD, they struggle with new users or users with very few readings, a classic co-star problem. And initially, these users received poor recommendations due to lack of historical interaction data. And to address this, we incorporated metadata into our routing logic. And this allowed co-star users to benefit from the specialized model, which was trained to better handle sparse user profiles. And in the future, we plan to integrate more like content-based features like movie genres or user profiles to better help with the co-star problem. And then Miguel will talk about the teamwork reflection.
So our team organized very well which task everyone was going to do right from the first milestone. We would usually meet in the beginning of the milestone to discuss how we were going to move forward with our implementation and who was responsible to do what. Then we can track all contributions also in our GitHub repo. Some challenges we faced were firstly coordinating a core across schedules. Since aligning meeting times across diverse personal and academic commitments led to some delays in progress. Also, resolving some design disagreements, especially debates over system or model choices that required extra syncs and often slowed our decision making. And finally, we had a couple information overload where the volume of WhatsApp messages, sometimes buried in urgent action items, led to more progress and delays. Want to make a comment here that we had a great team vibes as a team, and we're all really happy with the way that we engaged over the semester, and we even ended up doing much more, many more social meetings than the ones that were required. So, reflecting on our future projects, maybe something that we will need to change is to provide more comprehensive documentation. So key decisions, API specs, architecture diagrams, having everything in shared wiki so that new members can wrap up instantly and handoffs never stall. Also, we do have to have adapting road mapping is built explicitly in with buffer zones and pivot points in schedule to accommodate unexpected mistakes. And finally, we need to have more regular checkups when we hold mid and post milestone retrospectives to surface pain points early and evolve our processes incrementally. Thank you, and I hope you enjoyed this closer look into our project.